Volume by washer method. Suppose we wanted to find the volume of the slice of pineapple that's shown here below. Which graph approximately models the cross-section that we would want to rotate about the x-axis? Would it be graph A or graph B? Take a moment to pause this video and think about it, and when you're done, unpause it. The answer is B. And the reason behind that is because rotating this rectangle that's further away from the x-axis about the x-axis will produce two cylinders, like an outer cylinder, which represents the outer section of this pineapple, as well as an inner cylinder, which represents the middle of the pineapple, which is missing. Now, can we use the disk method to find this volume? Why or why not? We actually cannot use the disk method because there's a gap between the functions and the x-axis. Like we have this outer radius and we have this inner radius going on there. So how do you think we need to change our formulas to account for this new situation? How do you think the steps to solve the problem will change? And answers to those questions will be found later on in this presentation. Computing the volume of a washer involves finding the volume of the inner ring and subtracting it from the volume of the outer ring. In other words, we're finding the volume of the cylinder that has a radius of capital R, and we are subtracting from this value the volume that has the inner radius of little r. And we can take a look at the dimensions of the washer that is shown below. So to find the volume of this washer, we set up the formula as explained, and substituting in the known values that we have here. So the volume of the outer cylinder is going to be pi times capital R, which is 1 squared, times the height of the cylinder, which is 1/4. And then we're going to subtract from that pi times the inner radius, which is 1/2, square that, and again the thickness or height of the cylinder, of the inner cylinder, is also 1/4. And then when we simplify this, we'll get pi over 4 minus pi over 16. So that's 4 pi over 16 minus 1 pi over 16, or 3 pi over 16 when we do the subtraction. And that's equivalent to about 589 thousandths cubic inches. And to borrow a phrase from a renowned calculus instructor, Lynn McMullen, in order to find the volume using washer method, you subtract the whole from the whole in terms of whole thing. So the washer method calculates the volume of a solid of revolution by breaking it up into smaller washers, as demonstrated below with this pineapple in the picture. Notice that the goal is not to find the volume of a slice of pineapple. Instead, the goal is to find the volume of an entire pineapple, or all of these slices added up. And by stacking an infinite number of washers of infinitely small thickness, dx or dy, our volume will be more and more accurate. In other words, as with the disk method, the thinner the slice yields a more accurate volume. Click on the link below to launch a 3D simulation of what occurs when we use the washer method to find volume. So if I click on this link, it takes me to this website that others have created, which is pretty neat. And we can set n to be whatever value we want. Same with k, it can be any value. This is the axis of revolution that's being used. I'm going to try to keep it at 0 so that it's the x-axis for now. And if we start to revolve it, we can see the washer that's being created here. So that's one washer. And if we take our XCS value, we can see how in the graph over here to the right, the radius value or the thickness of our washer is changing by subtracting the outer inner radius from the outer radius. And we can see it expands up to here, and it starts to shrink down a little bit and become a thinner washer again as it approaches the intersection point. So the volume formula that we're utilizing here is finding the volume of each of these little washers that we're calculating the volume of, and then we're adding them together. So the washer method allows us to break up a complex solid into smaller, less complex washers, which we know how to find the volume of using the formula from before, when we subtracted the smaller radius volume from the bigger radius volume. So we had pi times capital R squared times h minus pi times little r squared times h. And in the case of the solid of revolution, we can adapt capital R, lowercase r, and h to be the following. So this outer radius, or capital R squared, becomes capital R of x, which is its own function. And we're going to square that function. And the height is going to be delta x, or dx. And then the smaller radius is going to be lowercase r of x. We can now use integration again to create a formula for finding the sum of an infinite number of washers of a solid of revolution within the closed interval from A to B. The formula for a revolution around a horizontal axis is going to be that the volume is equal to pi times the integral from A to B of capital R of x squared minus little r of x squared, and we're going to integrate that whole thing with respect to x. The formula for a revolution around a vertical axis is going to be very similar, but instead of capital R of x squared minus little r of x squared with respect to x, we're going to have capital R of y squared minus lowercase r of y squared.